Okay, so now the last topic of this chapter is the parallel and series connection. Series connection of capacitor, not resistor, capacitor. Okay. If there is any confusion in any topic, you can ask any sort of question. Okay. So the actually up till we study about the series and parallel connection of resistor. If you want to connect resistor in series, then the equivalent resistor will be equal to the summation of all these resistors. Now your equivalent resistor will be equal to R1 plus R2 plus R3. If you have parallel connection of these resistors, then the equivalent resistor will be equal to then the parallel connection will be equal to 1 by R equivalent is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Or you can find it by like your R equivalent will be equal to product of two resistors. If this is three resistors, then you will take product of two resistors. If it is one resistor, if it is three resistors, you will take product of all three resistors. If two resistors, you will take product of two resistors. If here in this case we have three resistors, so that's equal to R1, R2, R3 divided by here we have three resistors, so you will take two resistors, then take like this, like R1, R2 plus R2, R3 plus R3, R1. Okay. If you have two resistors that is in parallel, this is R1, R2. So your R equivalent, in this case, it is simple, R1 plus R2 plus R3. But in this case, it is a bit complex that you will find 1 by R is equal to 1 by R2. This will be a time consuming. But this formula will be easy, like your R equivalent will be equal to here 3 resistors, so product of 3. If 4 resistor, product of 4. If 5 resistor, product of 5. So in this case, product of 2 resistor divided by if 3 resistor, product you will take 2 resistor over here, plus 2 plus 2. If 4 resistor, you will take 3 resistor over here, plus 3 resistor plus 3 resistor. If 5, then you will take 4 resistor over here, plus 4 resistor over here, plus 4 resistor. So in this case, we have 2 resistor, so I will take 1, R1 plus R2. So this will be your equivalent resistance value. Now, come toward the capacitor. So capacitor is actually we have three types of component. One is the peso component. I discussed this peso component. That is three types. One will be a resistor. Second one is the inductor, and third one is the capacitor. So parallel and series combination of resistor and inductor is same. If here you connect inductor like this, if three inductors are in series, L1, L2, L3, okay, we represent inductor by this symbol. So if you want to find the equivalent inductor value, then that will be like resistor L1 plus L2 plus L3. Similarly, if you want to connect inductor in parallel, so that will be same. This is L1, this is L2. So your equivalent will be equal to L1, L2 divided by L1 plus L2. Now, capacitance is different, okay? Capacitance is like if lots of capacitor, if three capacitor is given to you, this capacitor is C1, this is C2, this is C3. And you want to find the equivalent capacitance value, so that should be like this. For series, that should be 1 by C1 plus 1 by C2 plus 1 by C3. Okay? Or C equivalent is equal to the product of all capacitance C1, C2, C3 divided by C1, C2, C2, C3 plus C3, C1. And in parallel, if you want to connect these capacitors in parallel, then the capacitance value will be same. That will be C1 plus C2 plus C3. Okay, this is for this. Okay. Now the question is,
Sir, I can't hear you. Sir, I can't hear you.
Hello? Hello?
Yes, sir.
Okay, so you got all these concepts
Yes, sir.
and these, all these?
Yes, yes.
Okay. So why we are going to do the series and parallel connection of resistor, of inductor, of capacitor? Let's say resistor. Why we are going to make the resistor in series and resistor in parallel? Think about it and give me answer. Okay, so the answer is actually now the question is why we are going to use the series connection of resistor and why we are going to use the parallel connection of resistor. This is R1, this is R2, and this is R3. This is R1, R2, and R3. Okay, so if in your lab,
We connect in series so that the voltage is not lost.
we connect it in series so that the voltage is not what?
It's not dropped.
Is not absorbed.
Dropped.
Is not drop. No, it will drop. If you connect voltage across this, then there will be some sort of dissipation of voltage across this resistor, and that voltage will be equal to current flowing in this resistor I R R1. V1 voltage will be different. V1 voltage will be equal to current which is same flowing. This is in series, same current time R1. Okay, so there will be dissipation of voltage in the resistor because this is the resistor. In the resistor there is dissipation. There is a dissipation of voltage. In inductor and capacitor there is no dissipation of voltage. Voltage will not lose in the form of heat in capacitor and inductor, but in this case voltage will lose in the form of heat. Okay, actually we do that if in lab you have lots of resistor. Okay, in lab you have 1 ohm resistor, you have 2 ohm resistor, you have 3 ohm resistor. Okay, but you require 10 ohm resistor. What you will do? This is lots of resistor. R2 is 2 ohm resistor is also load, 3 ohm resistor is also a huge number. But your requirement is 10 ohm. Then what you will do? You will connect it in series or parallel?
For series.
Yeah, you will connect it in series. So you will take this resistor R3 plus R3, that is 6 plus R3, and you will take 1 ohm resistor. Okay, so you will connect that in series. Okay, good. Now if your requirement is 0.5 ohm, then what you will do? Resistor is 1 ohm, 2 ohm, 3 ohm.
So then in parallel.
Yeah, you will do in parallel. How you will do that in parallel? You will take which resistor and connect that in parallel. If I take 1 ohm, then the resistor value will be equal to 1 times 1 is 1 divided by 1 plus 1 is 2, and that is 0.5. Yes, you will take 1 ohm resistor and connect that resistor in parallel. Okay, so actually the series connection will give you the equivalent resistance, and that equivalent resistance will be greater than the higher value of the resistor. In this case, the higher value is 3. So if you connect any two resistors in series, okay, then the resistance will be greater than the equivalent resistance will be greater than the higher value of the resistor. In all these three resistors, the higher value is 3 ohm. Okay, so if you take this resistor and connect in series with this resistor and connect that in series with this resistor, so in all these three resistors, your equivalent will be equal to 5 ohm, 3, 4, 5, no, 6 ohm. Your equivalent will be equal to 6 ohm. And 6 ohm will always be, your equivalent resistance will always be greater than the greater resistance of all these three resistors. In this case, the greater resistor is 3 ohm. So in series, the equivalent resistance value will be greater than the greater resistor of this resistor. Okay, got it? In parallel, the equivalent resistance will be less than the smaller resistance of all these three resistors. If you connect these three resistors in parallel, then your equivalent resistance value will be less than 1 ohm. In all these three, lower resistor value is 1 ohm, so you will get a low equivalent resistance, and that is less than the lower value of these three resistors. Now, if you connect this resistor in parallel, okay, so that will be product of three resistors. Equivalent will be product of 3 times 2 is 6, 6 times is 6. Product of 2 resistor, 1 times 2 is 2, plus 2 times 3 is 6, plus 3 times 1 is 3. So that will be 6 divided by 6, 7, 8, 9, 10, 11, 11. So 6 divided by 11, that is that will be in point, something point. Okay, that will be actually 60, that will be 0.5, 55, so 0.55, which is less than the lowest resistor. Lowest resistor value is 1, which is less than 1. So your equivalent resistor, that will be less than the lower value resistor. Lower value resistor is 1 in this case. Okay, and if you connect all that resistor in parallel, but if you connect all that resistor in series, then the equivalent resistor resistance value will be greater than the greater resistor value. In this case, that is 3. Got it?
Yes, sir.
Okay, so this is the end of this chapter, and you try to solve all the numericals, okay, and also try to solve some past paper during free time. If you have free time, then solve the past paper question, okay. And if there is any difficulty, then we will clear that difficulty in next class. And in next class, we will start the electronic chapter.